Today we are going to begin with the derivative of trigonometric functions. So here we have the 6 formulas to find the derivative of trig functions. The first one is the derivative of sine x is cosine x. Second, derivative of cosine x is negative sine x. Derivative of tangent x is secant squared x. Derivative of cotangent x is negative cosecant squared x. Derivative of secant x is secant x multiplied to tangent x. And derivative of cosecant x is negative cosecant x cotangent x. We can prove all these formula using the definition. If you use the definition of derivative, we can easily find the derivative of sine to be cosine, cosine to be negative sine, and so on. But in today's example, what we are going to do is we are going to directly use this formula to find the derivatives. Example, find the derivative of the following functions. Part A, we have y equal to e to the negative 5x multiplied to cosine 3x. So part A, we have y equal to e to the negative 5x multiplied to cosine 3x. So here we have the product of two functions, e to the negative 5x multiplied to cosine 3x. So if we have a product, our first step is to use the product rule. So dy over dx will be, the derivative is equal to first function, which is e to the negative 5x, multiplied to the derivative, which is d over dx of second function, which is cosine 3x, plus the second function, which is cosine 3x, multiplied to the derivative of the first function, which is cosine 3x. Derivative of second function, which is e to the negative 5x, in fact. Okay, so it is first function times the derivative of second plus second function times the derivative of first. So here I use the product rule because we have two functions in the form of product. Now, in next step, we have e to the negative 5x multiplied to, here we have derivative with respect to x of cosine 3x. If it is only cosine x, it will be negative sine x. But here you have cosine 3x. This is composite function. Your outside function is cosine and inside function is 3x. So here we have to use the chain rule. Chain rule says derivative of outside function, there's derivative of cosine, which is negative sine. Okay, negative sine 3x. Then we multiply by the derivative of inside function. Inside function is 3x. So we multiply by the derivative of 3x. Then this plus sign. Then we have cosine 3x. Cosine 3x multiplied to, this is derivative with respect to x of e to the kx. Derivative with respect to x of e to the kx is k times e to the kx. Our k is negative 5 times e to the kx, which is negative 5x. This is equal to e to the negative 5x multiplied to negative sine 3x multiplied to derivative of 3x is 3, because 3 is a constant, so we pull it out because here we have a constant multiple, and derivative of x with respect to x is 1, so 3 times 1 is 3, plus we have cosine 3x times negative 5 times e to the negative 5x. Now I'm going to simplify everything. Let's see what we get. So if you multiply this, e to the negative 5x and negative sine 3x times 3, if you multiply all these, the product will be negative because there is a minus there. Negative 3, okay, let me write this. Negative 3 e to the negative 5x multiplied to sine 3x. Similarly, if you look at the second product, this is negative. So when you multiply all these, the product will be negative times this positive, that is negative 5. Then we have e to the negative 5x, and also we have cosine 3x. Now, if you look at this carefully, you'll see that in both terms, there is a negative and also there is e to the negative 5x. So that is common. We can take that out. negative e to the negative 5x out. Factor that out, then you're left with 3 sine 3x. 3 sine 3x. We factor out the negative, so it will be positive. We factor out e to the 5x, so you have 5 cosine 3x. 5 cosine 3x. So this is the derivative of the function y equal to e to the negative 5x times cosine 3x. Part B. In part B, we have y equal to cosine x divided by 1 minus sine x. So you can see that this is the quotient because you have a numerator over denominator, cosine x divided by 1 minus sine x. Because this is in the form of quotient, we are going to use quotient rule first. So the derivative of y with respect to x is equal to, if we use the quotient rule says denominator, which is 1 minus sine x, denominator multiplied to the derivative of numerator, derivative with respect to x of the numerator. In the numerator, we have cosine x, minus the numerator, which is cosine x, times the derivative with respect to x of the denominator, which is 1 minus sine x, all divided by the square of the denominator. So which is 1 minus sine x is the denominator, square of that. So we use the quotient rule in first step. So this is equal to, we have 1 minus sine x multiplied to, here we have derivative of cosine. Derivative of cosine is negative sine. So derivative of cosine, that will be negative sine x, negative sine x, then minus cosine x, this one, times derivative of 1 is 0, because derivative of constant is 0, minus the derivative of sine. We are finding the derivative of this sine. Derivative of sine is cosine. So that is cosine x. Let me write that. Cosine x. And we are dividing all this by square of the denominator. 1 minus sine x squared. Now let's simplify. In the numerator, when I multiply or when I distribute that negative sine x here, negative sine x multiplied to negative 1 is negative sine x. And then negative sine x multiplied to negative sine x, negative and negative positive. Sine x times sine x is sine squared x. Then minus, see 0 minus cosine x is negative cosine x. Negative cosine x multiplied to negative cosine x is positive cosine squared x divided by 1 minus sine x quantity squared. Now, in the numerator, if you look at this carefully, here we have sine squared x plus cosine squared x, which is 1. Then we have a minus sine x here. So in the numerator, I have 1 minus sine x. And in the denominator, I have 1 minus sine x quantity squared. Meaning of that is 1 minus sine x times 1 minus sine x. So by writing like this, you can see in the numerator, I have 1 minus sine x. In the denominator, I have 1 minus sine x. So I can divide that. 1 minus sine x over 1 minus sine x, that will be 1. So my result is 1 in the numerator and 1 minus sine x in the denominator. So 1 over 1 minus sine x is the derivative of this function, which is y equal to cosine x over 1 minus sine x. Part C, we have y equal to tangent 5x squared. So part C, we have y equal to tangent 5x squared. We have to find the derivative. Dy over dx is equal to, when you find the derivative of this one, this is not just tangent x, but it is tangent 5x squared. Your inside function is 5x squared and outside function is tangent x. So this is the composite function. So if it is a composite function, we have to use the chain rule. And chain rule says derivative of outside function multiplied by the derivative of inside. So derivative of outside, derivative of tangent is secant squared. So secant squared, inside that we have 5x squared, keeping the inside same. Then multiply by the derivative of the inside function, which is 5x squared. That's equal to secant squared times 5x, secant squared of 5x squared, multiply to derivative of 5x squared. Here you can use the power rule. You bring that 2 down. So 5 times 2 will be 10. And you reduce the power by 1. So here is x squared. If you reduce the power by 1, that is 10x. So you can write that 10x in front. So 10x multiplied to secant squared 5x squared. That is the derivative of the function y equal to tangent 5x squared. Part D, we have sine y squared plus 3x equal to e to the 2y. And this is your implicit function. This is implicit function because you cannot solve for y easily. So because this is implicit function, we are going to use the implicit differentiation. So first, if you want to find the derivative of this one, you can see you have sine of y squared. Inside function is y squared, outside function is sine. So we use the chain rule first to find the derivative of the first term. So derivative of sine is cosine. So you can write that as cosine y squared, multiply by the derivative of inside function, derivative of y squared. So here we use the power rule. Derivative of y squared, if you use the power rule, 2 will come in front. So it will be 2y. But you are differentiating y with respect to x. So always you have to multiply by dy over dx if you are differentiating y with respect to x. That is the main thing that we have studied in implicit differentiation last week. Then we have a plus. You are differentiating 3x with respect to x. 3 is a constant because it is a constant multiple. Derivative of x is 1. So 3 times 1 is 3. Equal to, on this side you have e to the 2y. So whenever you want to find the derivative of e to the kx, it is k times e to the kx. So k is 2 e to the kx. But if you look at it carefully, this is not x, this is y. So whenever you are differentiating y with respect to x, it is the implicit differentiation. So you have to multiply by dy over dx. So we use the implicit differentiation. That is, we differentiate each term with respect to x in the first step. Okay, here my first term is 2y multiplied to cosine y squared. 2y multiplied to cosine y squared times dy over dx. I'm looking for dy over dx. So I'm going to move this term on the left-hand side. So it will be minus 2 e to the 2y times dy over dx. And then I'll move this 3 to the right-hand side. So it will be negative 3. Moving 3 on the right-hand side, meaning of that is I'm subtracting 3 on both sides. So that is negative 3. The reason is I want to find dy over dx. That is the derivative. So now in the second term, we have dy over dx. In the first term, we have dy over dx. So I'm going to factor that out. Dy over dx, if I factor that out from the first, I have 2y times cosine y squared. 2y times cosine y squared. And then minus from the second, when you factor this one out, you have 2 e to the 2y. 2 e to the 2y equal to negative 3. So in next step, if you want to find dy over dx, what we have to do is we have to divide on both sides by this quantity so that this one will get cancelled on the left hand side. We are left with dy over dx. On the right hand side, it will be negative 3 over 2y cosine y squared minus, I'm dividing by this one, so 2y cosine y squared minus 2 e to the 2y. So this is the derivative of the implicit function, which is given here in part D. Example, find an equation of the line tangent to the curve f of x equal to cosine x over 1 minus cosine x at x value equal to pi over 3. We are also asked to sketch the graph, okay, of this function and also the tangent line together. So let me sketch the lines here and then the graph. So this horizontal line is my x-axis, vertical line is my y-axis. And then if we draw this graph just around the y-axis, okay, if you try to sketch that function just around the y-axis, you can use calculator for this. It will look something like this. And also here, it will look something like that. And if you want to draw the tangent at x equal to pi over 3, then x equal to pi over 3 is somewhere here. This is x equal to pi over 3. I don't know the y value yet, so I'll write that later on. So my tangent line will be something like this. Okay, it will touch there. And this will be my tangent line. That means when you go from left to right, the line is going down. So my slope should be negative. Okay, and also the second thing that I can see is this line, the tangent line will cross the y-axis somewhere there. So the y-intercept should be positive. That is what I know. First, let's find the point, because we need the point and the slope to find the equation of the tangent line. So for the point, it is at x equal to pi over 3. So we plug in pi over 3 on this function. So here, if you plug in pi over 3, the value of the function at pi over 3 will be cosine pi over 3 divided by 1 minus cosine pi over 3. Cosine pi over 3, if you remember from your trig class, it is half. And then 1 minus cosine pi over 3 from trig class using unit circle is half. So half divided by 1 minus half, that's also half, which is equal to 1. So it is pi over 3 comma 1. That is the point. So our point is, let me write here, the point at which we are calculating the tangent line is pi over 3 comma 1. So that is the point. We need the point and the slope. Next step is to find the slope. Now let's find the derivative of this function f of x. Derivative, you can write this as f prime x as the derivative. And this is in the form of a quotient, numerator over denominator. So we are going to use the quotient rule. Quotient rule says denominator, which is 1 minus cosine x, times the derivative of numerator. Numerator is cosine x. The derivative of cosine is negative sine x. So the derivative of numerator is negative sine x. Minus the numerator, cosine x, multiplied with the derivative of denominator. Derivative of this is 0, minus derivative of cosine x is negative sine. And here is also negative, so it becomes positive sine x. Divided by the square of the denominator. So 1 minus cosine x. Now let me simplify this a little bit. So here, if I distribute this sine x here, negative sine x multiplied to 1. Negative sine x multiplied to negative cosine x is positive sine x cosine x, or cosine x sine x, which is the same thing. Then minus, we have cosine x sine x divided by 1 minus cosine x quantity squared. Now, if you look at the numerator carefully, you'll see here we have positive sine x cosine x, and here we have negative cosine x sine x, which is the same thing, but opposite. So those two get cancelled. Those two get cancelled. And my derivative will be, in the numerator, I only have negative sine x. Negative sine x. And in the denominator, we have 1 minus cosine x quantity squared. So that is the derivative. So once we know the derivative, we can find the slope. And in order to find the slope, all I have to do is I have to plug in pi over 3. So let's plug in pi over 3 to get the slope. So slope m is equal to, if we plug in pi over 3, it will be negative sine pi over 3, negative sine pi over 3 divided by 1 minus cosine pi over 3 squared, which is equal to negative sine pi over 3. If you remember from your unit circle, the value of sine pi over 3 is square root of 3 over 2. And then 1 minus cosine pi over 3 is half, which is equal to negative square root of 3 over 2 divided by 1 minus half is half, and square of half is 1/4. And negative square root of 3 over 2 divided by 1/4 is negative 2 square root of 3. So that is the slope. We got the point here and we got the slope. Now we are ready to find the equation of the tangent. Now let's find the equation of the tangent line. So if you remember, the equation of tangent line will be y minus the y1. y1 is the y value over here, which is 1, equal to m, slope, which is negative 2 square root of 3, x minus the x1. x1 is pi over 3. Now if we simplify this, let's see what we get. On the left hand side, I have y minus 1 equal to negative 2 square root of 3 multiplied to x. And then negative 2 square root of 3, if you distribute there, negative and negative will be positive. Then you have 2 square root of 3 multiplied to pi over 3, which will be 2 square root of 3 pi over 3. So y is equal to, now we have to write our final answer in the form y equal to mx plus b. So mx, which is negative 2 square root of 3x, negative 2 square root of 3x. Then plus, here we have 2 square root of 3 pi over 3, 2 square root of 3 pi over 3. And if you move this 1 over, it will be plus. So that is a constant. I can write that as a y-intercept inside the parenthesis. Now you can see we have y equal to, this is my slope multiplied to x, mx, and this is a positive b. So that is the equation of this tangent line. Slope is negative, as I told you. When you go from left to right, it's going down. And y-intercept is this one, which is a positive quantity, because this line crossed the y-axis at some point above the x-axis. So that's positive. So this is the equation of the tangent to the graph of this function at x equal to pi over 3. Example, for what value of x does y equal to x minus sine x have a slope of 1? When we say slope 1, meaning of that is derivative is equal to 1. Slope of 1, meaning of that is the derivative is equal to 1. So if derivative is equal to 1, what is that x? That's what we have to find. So first, we are going to find the derivative of this function. So here we have the function y equal to x minus sine x. If you want to find the derivative, it is dy over dx is equal to, derivative of x is 1. With respect to x, it is 1. Derivative of sine x is cosine x. So the derivative is 1 minus cosine x. Now, for the slope is 1, meaning of that is this derivative, that is 1 minus cosine x, is equal to 1. Now, let's write that down. Now, this derivative, which is 1 minus cosine x, is equal to 1. So derivative is 1. Now, if I subtract 1 on both sides, I get negative cosine x equal to 0. Or if I divide on both sides by -1, I get cosine x equal to 0. Cosine x equal to 0. So cosine x equal to 0, we have to find the value of x. So for what value of x the cosine is 0? If you remember, the x will be pi over 2 and 3 pi over 2 in your unit circle. At pi over 2 and 3 pi over 2, cosine is 0. So the slope is 1 at x equal to pi over 2 and x equal to 3 pi over 2. So we can write the slope is 1 at x equal to pi over 2 and x equal to 3 pi over 2. Example, for what value of x does y equal to x minus 2 cosine x have a horizontal tangent line? Horizontal tangent line, meaning of that is the tangent line is parallel to x-axis. Or when the tangent line is horizontal, the slope is 0. For the horizontal tangent line, the slope or the derivative is 0. That is the meaning of that. Horizontal tangent line, the slope is 0. So first we are going to find the slope or the derivative, and we have to equate it to 0 to find the value of x. So let's begin with the given function. We have y equal to x minus 2 times the cosine x. Now let's find the derivative. Dy over dx is equal to, derivative of x is 1, then minus 2, because this is the constant multiple, so I can just write that 2 as it is. Derivative of cosine x is negative sine x. Negative sine x. So if we simplify that, dy over dx, the derivative is equal to 1, negative 2 multiplied to negative sine x. Negative times negative is positive 2 sine x. So that is the derivative. Now, for the horizontal tangent line, the derivative must be 0. So my derivative, which is 1 plus 2 sine x, that must be 0. If I want to find the value of x, now I need to subtract 1 on both sides. So 2 sine x is equal to -1. If I want to find sine x by itself, I have to divide on both sides by 2. So it will be -1 over 2. So sine x is -1 over 2. If you remember in your unit circle, okay, if you remember in your unit circle, x must be equal to, for x to be -12, if you look at your unit circle, or if you remember your unit circle, x is 7 pi over 6, 7 pi over 6, and x equal to 11 pi over 6. So at x equal to 7 pi over 6 and 11 pi over 6, sine x is negative. So meaning of that is, at x equal to 7 pi over 6 and 11 pi over 6, the tangent line is horizontal. So the result is, let's write down the final answer. So at x equal to 7 pi over 6 and x equal to 11 pi over 6, the tangent line is horizontal. Example, an observer stands 300 meters from the launch site of a hot air balloon. The balloon rises vertically at a constant rate of 5 meters per second. How far is the angle of elevation? How fast is the angle of elevation increasing 45 seconds after the launch? So the hot air balloon is rising vertically upward. Maybe somewhere there it's rising up like that. And there is an observer which is who is standing 300 feet or 300 meters from the launch site. So somebody is looking from here, which is 300 meter from where this hot air balloon is going up. Now, what they have given is the balloon rises vertically at a constant rate of 5 meters per second. If this vertical height is y, okay, if we consider the vertical height as y, then they have given, if the vertical height is y, they have given that dy over dt, the rate at which the height is changing is 5 meters per second. That is equal to 5 meters per second. So every second, in 1 second, the height is increasing by 5. So in 10 seconds, it will be 10. In 3 seconds, in 1 second, it will be 5. 2 seconds, it will be 10. 3 seconds, it will be 15, and so on. That's how the height is increasing. Now, what you have to do is, how fast is the angle of elevation increasing 45 seconds after the lunge? When we say angle of elevation, this is the angle. This angle here, that is the angle of elevation. You know that when the balloon rises upward, this observer who is looking at the balloon, he will be looking up every single second. Meaning of that is this angle will be increasing continuously. So we have to find the rate at which it is increasing when the time is 45 seconds. So this is something we are calculating at 45 seconds, t equal to 45 seconds. So at 45 seconds, if you want to find the height, okay, if you want to find the height at 45 seconds, every second the balloon is increasing at a height of 5 meters. So it will be 5 times 45, which is equal to 225 meters. So at 45 seconds, the height is 225 meters. So at this time, when the balloon is at 225, okay, when this height is 225, we have to find the rate at which the angle is changing. So what we know is tangent theta is equal to the opposite over the adjacent. This opposite side is continuously increasing as the balloon rises up. So we don't have a fixed value in general because it is always increasing. So I'm going to write that y divided by the adjacent side is 300 meters, so 300. Or if you want to write it a little differently, this will be like tangent theta equal to 1 over 300 multiplied to y, which is same thing. Y over 300 is same as 1 over 300 times y. So now this function, we can differentiate on both sides using implicit differentiation. So if I use the implicit differentiation and I'm differentiating with respect to time in this case, because we are measuring the rate, so derivative of tangent theta is secant squared theta, because derivative of tangent is secant squared, and I'm differentiating with respect to time, and this is the angle. So if you use the implicit differentiation, it will be d theta over dt equal to, on the other side, you have 1 over 300 is a constant multiple, so that will stay there. And derivative of y with respect to t, we are differentiating with respect to time. So that will be dy over dt. Dy over dt. So we perform the implicit differentiation in this step. So at 45 seconds, at t equal to 45, your tangent theta will be, okay, at 45 seconds, your tangent theta will be, you know that tangent is opposite over adjacent, so it will be 225 over 300. 225 over 300. Okay, at 45 seconds, 45 not degree, at 45 seconds, your tangent theta will be 225 over 300, because at 45 seconds, your height is 225. So if I want to find this theta, theta will be equal to tangent inverse 225 over 300. So theta will be equal to, if we simplify this using calculator, you can also try in your calculator, but your calculator must be in radian mode. So tangent inverse 225 divided by 300, your angle should be 0.6435 radian. 0.6435 radian. Now, once we have this angle, let's plug in here. So that will be secant squared 0.6435 d theta over dt. We need to find this because this is the rate at which the angle is changing, equal to 1 over 300 multiplied to dy over dt, the rate at which the height is changing. They have given here dy over dt is 5. So this value is given to you. That is 5. So d theta over dt, that's what I'm looking for, is equal to, here we have 5 multiplied to 1 over 300, which is 1 over 60, because 5 goes into 360 times. And then, in order to get d theta over dt, you are dividing on both sides by secant squared. So dividing by secant squared on right side is same as multiplying by cosine squared 0.6435, because dividing by secant is 1 over secant, and 1 over secant is cosine, because secant and cosine are reciprocal of each other. So we can write like that. Now we can simplify this using calculator to get our final result. So when we simplify, we get 0.0107, as this is the change in angle with respect to time. Your unit of angle is radian and time is second. So the angle of elevation, this angle is increasing at the rate of 0.0107 radian per second.